This, as I'm sure you know, is a cathode ray oscilloscope. It's essentially a fancy voltmeter, which allows us to display and measure varying voltages. Now, when you pull one of these things out of the cupboard at school, first thing to do obviously is to turn it on, and you might sometimes get nothing on the screen. Now, if you're faced with this, the best thing to do is to fiddle with these X and Y controls to get something on the screen like this, and you can see that's not looking terribly helpful either. So the next thing to do is to turn the time base right down to 0, and what you should end up with is a dot. Now this one's slightly out of focus, and I can adjust that by twiddling this focus knob. So I've got a focus dot. I'm now going to bring it into the center of the screen by once again adjusting these X and Y controls. So now it's ready to use, and the first thing I'm going to do is measure a DC voltage. I've got some batteries here. Now, like any voltmeter, the oscilloscope has got two terminals. And if I connect it to a battery, this is what happens. You should have seen that the dot jumped up by about 1.5 divisions. And the scale here is set at 1 volt per division, which tells me that I'm measuring a voltage of about 1.5 volts. And if I add another battery, you see the dot jumps higher, and a third battery, it jumps higher still. Now, if I connect the battery the other way round, you see that the dot moves in the opposite direction. If I change the volts per division to 0.5, you see the dot moves twice the distance. And if I move it to 2 volts per division, this is what happens. You can see that by adjusting the volts per division, I can change the sensitivity of the voltmeter. Now let's look at a varying signal. I'm going to use a signal generator, and if you're going to connect a CRO to a signal generator, you've got to use the high resistance output. You can see the dots now moving up and down, and that's because I've got a voltage that's oscillating at about 0.5 hertz, so it's completing a cycle every 2 seconds or so. This is what happens when I increase the frequency to 5 hertz. You can see, obviously, the dots moving up and down a lot quicker. This is what it looks like at 50 hertz. Now I've just got a straight line, and that's because the dot is moving up and down so quickly. We can look at a signal like this more closely by adjusting the time base. I'm just going to center it again using the X control. And you can see I've now got a lovely sinusoidal trace. It's effectively a voltage time graph with voltage on the y-axis and time along the x-axis. And I can actually take measurements directly off the screen. You can see that from peak to trough, it's about 8 divisions. So the amplitude of the trace is 4 divisions. And I've got the sensitivity set at 1 volt per division, so the amplitude of the output voltage is 4 volts. I've got 5 complete cycles here across 10 divisions, which means 1 cycle across 2 divisions. The time base is set at 10 milliseconds per division, which means a cycle takes 20 milliseconds. That's a frequency of 50 hertz, which is exactly as expected. I've used the oscilloscope here for a relatively straightforward demonstration, but whatever experiment you're doing with it, what you're using the oscilloscope for is to display and measure varying voltages.